All right, let's get started. You want to start right off with, this is right where now the video is going to start up, because I want to point out number 2. Number 2, with this question is the building block of this rest of this week and the whole rest of this semester. That's how important this question is. This is the one where you had to use the Z-chart, which I forgot to open, by the way. So someone have the Z-chart open, ready to go, because I don't have mine open, and you can read it for me. All right? This said, assume that some data has a mean of 152, standard deviation of 32.6. Show your detailed work to calculate Z and give the probability from the Z-chart to find the answer to this question. What's the probability that a randomly selected sample data having the value of 142 or more? Notice it's not asking for a sample size bigger than 1. It says, what's the probability for a randomly selected sample data? Just 1. That's why this denominator is not 32.6 over the square root of the sample size, because we're only at a point to where the sample size is always 1, and the square root of 1 is 1, and the standard deviation divided by 1 is the standard deviation. So that's why that's all left off, but I keep reminding you, because we're heading to where we will have sample sizes larger than 1. That's where we're going in a couple of weeks. So this problem was easy, because all you had to do is take whatever you're being asked about, minus the given mean, then divide by the standard deviation. So 142, does it say or more? It's 142 or more. What the or more means, it should have said, okay, whatever I calculate and get down the Z-chart, I gotta find the opposite of it. Whatever I just looked up on the Z-chart, I gotta subtract from 1 to find the opposite. But you gotta show me what you got on the Z-chart, and then show me you're subtracting it from 1, or that you're at least finding the opposite. So 142 minus 152 divided by 32.6, that took us to negative 10 over 32.6, which took us to negative 0.3067, 4 digits to the right. You got all the points there. Some people stopped at that point and thought that was the answer. But you need to look it up on the Z-chart, but the Z-chart only goes 2 digits to the right of the decimal. So you had to round this to negative 0.31. That's what you looked up on the Z-chart. And then when we looked it up, I do have that on here. Using the Z-chart, negative 3.1 ended up being 0.3783. 0.3783. Okay, now some of you stopped there, so you kind of lost points. If you notice, subtracting it, doing this last step, subtract from 1. If you forgot to subtract from 1, and there's a couple of you that did, you lost a quarter of a point for not doing that last step. But what we really needed to do was find the opposite of this, which would have been 1.0000 minus 0.3783, which then gave you 0.6217. 0.6217. Now, that's acceptable right there. You did all this, there you go, you got all the points. Someone was going after the big points, so they said 62.17%. Didn't get anything, but I then said, oh, who's this? I'm trying to get familiar with you though, I like it, I like it. Putting that extra effort in, taking it all the way to the percentage. Like I know Stephen Hogan, I know him. Am I pronouncing it right? How? I'm not gonna forget Stephen. Stephen's got my attention. He found this too easy. Go ahead.
Would you do the same if it was for less?
Say that again.
Would you do the same if it was for less?
Oh, no. If she said, what if this were or less? If this, everything's the same except for this last step right here, and there's your answer right there when you looked it up. There's the or less. So everything's the same but that last step. You ready? Let's use Excel to solve it. So here, let me show you this Excel spreadsheet I posted. This is what we're learning today, and this is your homework. That you got to use Excel to solve it now. And on this spreadsheet, ignore the top right now. That's NORM.DIST. Look at that, S right there. Don't use that S yet. We're not at that point. That's next week. This week, we're on this middle one down here. Let me scroll down. Look, there's a bottom one. NORM.INV, we're not there yet. Ignore that one. We're on the middle one. Let me go up to the middle one. NORM.DIST or NORM.DIST. They do the exact same thing. They added the dot years later. I'm an old school, so I forgot the dot. But I put it up here with the dot. There it is. There's the one we're using. Now here's the deal. 4 numbers go in the parentheses. The first number is whatever the x is. Look back here. Whatever we're being asked the probability of. That left-hand side of that numerator is the x. So this is 142. Hang on, let me make it sloppy if I can. Hang on. There we go. Sloppy enough? There. All right. The second number is the mean in the story. In this story, the mean was 152. So comma, 152. The third number is the standard deviation in the story. Now we're heading to where that third number is the standard deviation over the square root of the sample size. And you would put that whole thing in here. You would put the standard deviation, and then you'd put the symbol for divide, and you'd put the square root, SQRT, we haven't learned it yet. You'd put that, and you'd put the sample, in parentheses, the sample size. That's where we're heading. For now, we just put the standard deviation only, because our sample size is only 1. So 32.6 is the third number. And now, the last number is either a 0 or 1, but are you taking notes? Are you ready? For normal distribution, we will always, always, always put a 1 for that last number. Everybody hear that? For normal distribution, and exponential, by the way. For normal distribution, when we get to exponential, I'll remind you, don't worry. For normal distribution, that last number in Excel, in the parentheses, will always be a 1. You can't lose points there. Put a 1. The question for normal will be just like your quiz. Let me get to that question again we just talked about. That question where it says, what is the probability for the value to be 142 or more? For normal distribution, I'll always ask about a number or more or a number or less. It will never be, what's the probability of an exact number? You can't do that with continuous data. So for normal distribution, that last number will always be a 1, and the question will always say, what's the probability of some number or less, or some number or more? The or less or more will always be in that question for normal distribution. It will never say exact like binomial does. So now, I'm going to put a 1 here. There it is. The last step is that this question on our quiz said 142 or more. So we got to put the 1 minus in front, but we do not have to change that number. For normal distribution, you keep that number just the way it is, whether it says or less or more. You put the number there that's being asked to find the probability of. Because this said find the probability of 142 or more, you put the 142 there. It doesn't matter. You don't use 141 like we do with binomial. That stays. You just got to make sure, remember to put the 1 minus in front. All right, let's do another one. This time, you ready to help me get this? Hang on. Equals norm dot DIST parentheses. This is an auto supply store. Now this is how it's really used in inventory control. This is real life. I've seen this many times. I used to work for a consulting firm, and I want to tell you, one of the major ways businesses were losing money or not maximizing profit is poor inventory management. And what inventory management is all about is the reorder points. Anybody taking out operations management right now at all? Raise your hand, please. Have you talked about the reorder point yet? Has it come up?
No.
It said no, but you said yes? No, reorder point? The reorder point is always based on the lead time. Now let me define these. A reorder point means whatever that item is, when it gets to a certain point in inventory, when it gets down, it goes down, we sold another, it goes down, sold another. When it gets to a certain point, the computer will notify you it's time to order more. That's called the reorder point, because you're going to run out if you don't order today. Everybody got that? That's the reorder point. The reorder point comes from lead time. Now let me define lead time. Have you had that operations yet? Lead time? Okay, what do you guys? What week is this? Do I need to go straighten out operations? What's going on over there?
We got enough.
You do have enough going on? Okay, all right. Lead time is the time it takes from a company placing the order to the order arriving at the dock. Let me say that again. From the time it takes that you go online, or in the old days, make the phone call to place the order, that date, to however long it takes them to order, the truck arrives at your dock, is loaded it into your warehouse. Whatever that time is, called the lead time. That lead time is the key to reorder points. Everybody get it? Now, if you could talk about that in an interview, and it's a job where you're gonna be managing inventory at all, you got the key words right there. Well, first thing I do is in your inventory is I look at all the reorder points and see if they make sense based on the lead time for each of those items. And then the interviewer is gonna look at you and go, okay, you got the job. Can you straighten out our lead times and our reorder points? Because that's what's causing companies to lose money, is they have so much money wrapped up in inventory that they don't have money to do other things or to expand. And so it's just sitting there in inventory. So companies years ago said, we need to create what's called inventory turns, that the full amount we have invested in inventory turns over as many times as possible in a fiscal year, which sometimes calendar year, all right? Inventory turnover. And the key to inventory turnover is that you don't have too much inventory, that you're reordering the exact amount it takes to where, well, here's the concept. As that truck's arriving, about to drop off what you ordered, and it's about to come into your warehouse, that last one that's available for a customer is just going up to the cash register and being sold. That's called just-in-time inventory system, and that's how you create the most turns. Everybody hear that? I want to describe that again so you can picture this. You're placing the order. The lead time has begun. Lead time's 3 days maybe. The truck's arriving, the goods are coming in, and you reordered based on a reorder point that was set maybe by someone else because you just got this job. And you're going, okay, how many are still in inventory because the truck just arrived? And you're going, wait, there's still 6 in inventory, and you're gonna start watching this because the goal is that you only have 1 in inventory as that truck's arriving and is coming into your warehouse. That you want to have as few in your warehouse as necessary to never lose a customer to a competition, but at the same time, never run out. Everybody hear that? Let me repeat that. That's a company's worst nightmare if they have strong competition, is running out. So they'll kind of inflate their inventory a little too much to avoid running out and losing that sale to a competition. Everybody get it? So it's all based on the lead time, then the reorder point. So now, to this story, so this all makes sense, because this is how it's really used in real life. When I'd go to companies, I'd say, let's start calculating your reorder points on this and this and this and this and this. And I start showing them how much money they're wasting in inventory. And you always come to like $50,000 a year wasted in inventory, easily. And sometimes that'd be on just maybe 2 or 3 SKUs, where they have 10,000 products that they inventory. I'd only evaluate 2 or 3 of their products, show them how much money they're losing just on those 2 or 3. And then the owners of the company would always open up their eyes and go, could that be happening with the rest of these 9,800 items? Yes, of course. That's exactly the point. And they're going, well, I need to hire someone that knows numbers. And these companies only are doing 14,000, 20,000 million, or I'm sorry, 14 million, 20 million sales a year. So sometimes it's like a mom and pop shop, and they don't have somebody who's graduated with a degree from the University of Michigan, Dearborn, that knows numbers and can calculate the correct reorder points. So Pep Zone, auto store supplies including multi-grade oil. The stock, when it drops to 20 gallons, the replenish orders placed. So the reorder point's 20 gallons. It's been entered in the computer. The computer knows every time an order arrives, it gets entered in the computer, all of a sudden inventory jumps from 20 to maybe 50. They're being sold, Every time it goes to the cash register, it's entered in the cash register, which is hooked up to the network. The inventory number drops. We're now at what I say we were at 50. Now we're at 49. Now we're at 48. Now we're at 47. Every time one sells, right? And all of a sudden that count on the inventory on the system gets to 20. You're the manager of this Pep Zone. You just got your report at the end of the shift. It's 4 o'clock in the afternoon, and there's the oil on the list that needs to be ordered tonight before you leave. You got to place that order. Go online, place. Okay, our supplier that does all the oils is this one. This web page is for everybody who does the brake pads. You have these different websites. Now you're placing these orders for the oil, placing these orders for the brake pads, placing these orders for the windshield wipers that you're down to the reorder point. That's how it works. You know the lead time, and that reorder point's based on it. Here's my question. What would you, managers, do to that reorder point if you're finding you're starting to run out and losing customers to the auto supply place down the road? What would you do to that reorder point? Would you raise it or lower it?
Raise it.
You'd raise the reorder point. What you're saying is you want to order sooner. You may be at 22 instead of 20, so you can stop running out, right? That you're selling more than the 20 you thought you'd be selling in the time it took for the order to arrive. That's exactly the concept. But it's all about what's the probability. So you use your past sales to figure out the probability of selling certain amounts. And that gets you a standard deviation also. Are you ready? Are we running out of time? Is that what that means? We gotta go? We're out? No in-class assignment? What? Wait, in-class assignments, we love those. It helps our grade, right? You don't love them, but you'll put up with them. So the manager of this is concerned that sales are being lost due to stockouts. All right? And so they're gonna go ahead and collect some data to figure out exactly how many we're selling of this particular oil over a certain period of time. It has been determined that demand during the replenishment lead time, however many days that is normally distributed at about 15 gallons with a standard deviation of 6. There we go. We did some research. In the 3 days or whatever the lead time is from the time we place from our supplier on this oil, we've found that we on average sell 15 gallons with a standard deviation of 6. Big standard deviation, by the way, so that means it fluctuates. And now you can calculate, as a manager, you can say, what if I want 50% chance of running out? And your regional manager goes, no, we don't want to take a 50% chance. Matter of fact, your regional manager may say, we only want about a 5% chance of losing that customer to a competitor. So I need you to set that reorder point for this to where we only have a 5% chance of losing the business to competitor. Or maybe they'll say, some companies will say, we definitely don't want to lose anything to a competitor. Or some will say, we won't lose that customer to a competitor. This item is not sold at our competitors, and so this customer will come back. So they'll say, let's set the reorder point to where maybe there's a 60% chance of losing that customer, because why not? Because they'll probably come back. It's something that's not available within a certain radius. And that's how it works in business. That's how the real reorder points are set, based on this kind of information. And you can calculate the probability based on the mean and standard deviation from how much you've sold of this product in the past over the same time period. 2 days, 3 days, whatever the lead time is. So here's the calculation. We want to know what's the probability we're going to run out. The mean is 15 gallons during those 3 days. The standard deviation is 6, but we're going to set the reorder point at 20. For us to run out, it means what's the probability we sell more than 20? Not less than 20, not exactly 20, more than 20. Help me out now. Are you ready? Let's do it manually. We'll set it up manually first. What is on the left side of my numerator here? What is the question asking about? How many? 20. What's the mean, the average amount we sell of this particular oil? 15. Very good. Divided by what's standard deviation? 6 equals 5 over 6, which equals 0.8 what? 83333? 0.83? Oh, is it on the PowerPoint? Is it on a PowerPoint? Oh, I thought you calculated. 0.8333, I think. We would then, now this we just calculated what we would look up on the Z-chart, but what we look up on the Z-chart answers the question, what's the probability we would sell 20 gallons or less? So we look up 0.83 on the Z-chart. Hang on, let's look it up. Here it is, 20 minus 15 divided by 6 is 0.83. We look at, here's 0.8, then we go to the 0.03, 0.7967. There we go. Where am I? Right here. 0.7967. But the question isn't about what's the probability we'll sell 20 gallons or less. It's saying, what if we run out? What if we sell more than the reorder point? What if we sell 20 gallons or more? So we got to find the opposite of this. Is that on here? It's got to be 1 minus 0.7967. The probability of us running out is about a 20% chance. Now here's the deal. This oil is at every one of our competitors. If we run out, they're going to go to our competitor and buy it. So, is it worth taking the risk of a 20% chance of losing the customer to a competitor? This is where statistics is used. This is where managers then can make a clear decision. And they'll say, no, let's do this calculation backwards. Let's take that to 10% and work it backwards and figure out what that 21 should be, or that 20, what's our reorder point, 20? What that 20 should be. Maybe it should be 21, maybe it should be 22. And that's how then inventory control, you get a handle on it. In other cases, inventory reorder points go down. And matter of fact, in most companies I used to work for the consulting firm and analyze, they needed to lower the reorder points. That's what I found was the most common mistake in inventory control, was that reorder point not being low enough. Let's go now, we're gonna use Excel. Here we go. First of all, is this a 1 minus or just a regular NORM.DIST? 1 minus because it's 20 or more. Okay, what's the first number? Can't hear you. 20, I heard it. Second number? 15, very good. What's the third number? 6. And what's always the last number? 1. There it is. You enter that in, you're gonna get really close to the opposite of this, which is 0.2033, or darn close to it. We're eventually need to get to the point to where we would calculate this backwards, and it happens on the PowerPoint, by the way. I forgot what percent, they want to get it down to 5%, that there's only a 5% chance of losing them to another customer. I'm not going to go over this one because this will not be on your next quiz to work it backwards, but you should know this, but I just want to show you. In real life, this is how it works. So you know they're going to raise that reorder point, right? So let's look. They want to take it from 20% chance of losing customers to 5% chance. So here it is. We're working it backwards. Okay, so at 5%, that means that this Z would calculate to 95%. And 95% is, we looked on the Z chart, 1.645, so we work it backwards now. We don't know what X is. We would make this the unknown. We'd have all this work backwards, but this 20 would be the unknown. And we're using algebra, and we work it backwards, and there it is. It says if you only want a 5% chance of losing the business to your competitors for that oil, you need to take the reorder point from 20 to 25. That's a big step up too. That's shocking how many you got to raise that reorder point up. But if that's the thing, it's going to cost money to have, that's more money wrapped up in inventory for more time, because now you're reordering at 25 instead of 20. But they're saying that the cost of having money wrapped up in inventory is better than the cost of losing the sale to a competitor if we run out. That's where managers make good decisions sometimes. All right? And that's why you got to use statistics to have all the clear information to make that clear decision. Going back through time and seeing what you sold in the past will help you predict the future. All accounting majors, where are you? Raise your hand, accounting majors. There's more than just one. Come on. No one else is going to be accounting major?
Who likes accounting?
What?
Who likes accounting?
Are you serious? Come on. Is this serious? Well, as somebody who most of my management career was in accounting or the business manager type person, I can't tell you how many times I use statistics to forecast revenue. You always got to make 5-year plans, and you got to keep updating. I had every expense planned out for the last 5 years, all the revenue for 5 years, all using statistics to predict those. All right. Now, we have one more thing to cover before our in class. How are we doing on time? 8 minutes. I'm going all the way to slide 4. You happen to get a PowerPoint. Oh wait, before I do that, I almost forgot. Week 4 instructions. Look at, there's only one assignment. It's called the written Excel assignment. And it's due in 2 days, but there's only, I think there's only 4 or maybe 5 problems on it, that's all. I think I opened it up, hang on. Here's the first one right there, second one right there, third one, fourth one. Here's the deal with the third and fourth one though, now that I look at it. It's asking you to do it twice. Let me make sure that's right. Yeah, the first one says manually calculate Z, go to the Z chart, get a probability. Then it says, then solve it again using NORM.DIST and give the result from that also. Now your results may be slightly different using Excel than looking on the Z chart, because the Z chart you're rounding. So it's not as exact. Excel is more of an exact answer, but they're barely going to be off, only like a little bit.
They're different numbers. One you're looking for 30.2 ounces or less, another you're looking for 34.
No, I'm not talking about 2 problems. You got to do each of these 2 problems twice. You got to do this one with 30.2 manually, then you got to do it with Excel 30.2. Then go to this one down here, use 34.5 to do it manually, then use 34.5 and use Excel to solve it. So you got to do that one twice, do that one twice, and these 2 up here, and that's it. These 2 up here are uniform distribution problems, which introduces us to which introduces us to right here. Uniform probability distribution. These are the first two problems on your homework that's due in 2 days. You now have all the information necessary to do those last two problems on your homework. This is for the first two problems. Number one step. How do you recognize a uniform distribution problem? It almost always has the words like evenly, the probability is evenly distributed, or it has the words, the probability is uniformly distributed between these two numbers. Let me repeat that. To recognize a uniform problem, it almost always has the words that the probability is evenly distributed, or it says something like the probability is uniformly distributed between these two numbers, whatever the two numbers are. So let me read one to you so you can see it. Slater customers are charged for the amount of salad they take. Sampling suggests that the salads taken are uniformly distributed between 5 and 15 ounces. That's how you recognize it. It gave you two numbers and it said evenly distributed or uniformly distributed between these two numbers. That's how you recognize uniform. So there's how you recognize it. Now let's go to this is the key to it, is the density function. I got it right here. You've got to have this. Uniform, put a big thing next to it. Density function is your first step. You take 1 over the largest minus the smallest number in that uniform distribution. It says this is evenly distributed between two numbers. Take the large one minus the small one, and it's below 1. Turn it into a fraction. So let's go back to the salad. Help me with the density function here. Where is the salad? This would be 1 over what?
15 minus 5.
I hear you.
15 minus 5.
15 minus 5. Take the largest number, 15 minus 5. Now this equals 1 over 10. There's the density function. Now, any question being asked about this salad, you got to take that density function and multiply it times whatever's being asked. Excuse me. You're going to take that density function and multiply it times whatever's being asked. The spread of whatever's being asked. Are you ready? 1/10 times, what's the probability the next salad coming up will be 6 ounces or less? 1/10 times the spread between 6 and 5. The lowest it could be is 5. What's the probability the next salad will be 6 ounces or less? So we have 1/10 times 6 minus 5. 1/10 times 1. So it's a 10% probability that the next salad coming up will be 6 ounces or less. Let's try another one. Let me get, I know you guys are writing these down. I want to erase them. Here's the next one. Hey, salads at this salad bar are evenly, always right around 15 to 5 ounces, and it's evenly distributed. What's the probability the next salad would be between 7 and 10 ounces? What's the probability the next salad between 7 and 10? Here we go. 1/10 times 10 minus 7. That's it. Whatever you're being asked about, the spread of what you're being asked about times the density function. So 10 minus 7 is 3. So 1/10 times 3 equals 3 over 10, which equals 0.3. 30% chance the next salad coming up will be between 10 and 7 and 10 ounces. Go ahead.
So the density formula, it says 1 over b minus a equals 0.
That's what I wanted to
That's
ask.
impossible to
Hang on.
Why?
Equals 0.
And not only that, it says
Ignore
1
the 0.
over b minus
Ignore the 0. Say it again.
And it says 1 over b minus a, but here you put 1 over 10, which is
Yeah,
the
1
highest.
over, B is the largest number, A is the smallest
A
number.
is the smallest number.
B is the largest
But-
number, A is the smallest number.
But in this case, why did you put 1 over 10 and then 10
Yeah,
minus
15
7?
minus 5 is 10.
To the one to the right. No, the one that we did right now. Yeah, this one.
That's because we're still doing the salad problem. You have to use that density function for every question that has to do with that salad. Let me try another one here so you guys get this. God, I can't think of a uniform distribution right now. I'm going to do another salad one, I guess. Hey, at this restaurant, okay, I've been to a Chinese restaurant that does buffets, you know, a buffet restaurant, right?
Yeah.
You bring it up, they weigh the plate, the scale takes in consideration, the plate weighs so much, and it's the food they're weighing really. And let's say the food is always between, let's say it's always between 3 and, I don't know, 12 ounces. Whatever, ounces, okay? OZ. What's the density function? What's the density function? How are you gonna get it?
1 over 3 minus 12.
That's it, 12
12
minus 3.
my bad.
1 over 12 minus 3 is the density function. Now, any question I ask about this buffet, it has to be multiplied by 1 over 9. 1 over 9 has to be multiplied by, now I'm gonna ask a question. 1/9 times what? What's the probability the next customer at this restaurant brings up a plate and the food weighs, 10 ounces or more? 10 ounces or more. I gotta use the density function. 1/9 times what? 10 ounces or more.
12 minus 10.
12 minus 10. The most it could go is 12. 10 ounces or more means from 10 to 12. 5 ounces or less would be 5 to 3. 10 ounces or less would be 10 to 3. You can't go outside the uniform distribution. The highest you can go and the lowest you can go are given in the story.
The larger number always goes first.
On the left, so you can subtract them. Yeah, you're never gonna have a negative. So this would be 2 times 1/9, or 2 over 9. 2 over 9, and this would give you 0 point, whatever the answer is. Let's do this one real quick. Ready? And where is it? Almost forgot. To find the expected value, to calculate it for a uniform distribution, it is add the smallest and largest number together and divide by 2. Add the two numbers, divide by 2. So the expected value or mean for a uniform distribution on this one between 15 and 5 ounces is a 10. The variance, now, don't ask me why you divide by 12. It's always been this way. But you take the largest number minus the smallest, square it, then divide by 12. So in this case, it would be the largest minus the smallest, which is 10, right? Squared, so 10 squared equals 100, and then divide by 12, which equals 8.333. I can't remember why you divide by 12. It's always been that way for uniform distribution. It's just always divide by 12. Put in your notes. Always divide by 12. So let's go with the salad. It's uniformly distributed between 15 and 5 ounces. And it's going to say, I can't remember, what's the probability the next customer is going to have one that weighs 12 ounces or more? 12 ounces or more. We got to use the density function, 1 over 10, because between 15 and 5 is the uniform distribution. 10 ounces or more, though, what am I putting in this parentheses? What am I multiplying it by? 10 ounces or more.
15 minus 10.
15 minus 10. That's exactly it. So which would be a 5. 5 over 10 equals 0.5. There is a 50% chance, and let's look at the answer. No, wait, 12 to 15. Oh, not 15 to 10. 12, which makes this a 3, which makes this 3. 30% chance. 12 to 15, not 10 to 15. So 12 or more. Go ahead.
But they're asking just for one. Whether it's 10.
It won't. We won't. And we'll just say, what's the next one? Not, and we'll say, what's the next 10's average? But, all right.